Now, let's proceed to Boolean identities. So, frequently, a Boolean expression is actually not in its simplest form. So, recalling from algebra that an expression such as, let's say, um, let's say 2x plus 6x. So this expression here, it's not actually in its simplest form. We can actually reduce this one represented by, let's say, mga fewer or simpler terms to, so this can be reduced to 8x. So, paano kaya natin ma-reduce yung mga Boolean expression? What are we going to use as a help to reduce a Boolean expression? So, Boolean expression can also be simplified, can be reduced. But we need identities or di kaya laws that apply to Boolean algebra instead of regular algebra. So basically, these identities which apply to single Boolean variable as well as mga Boolean expression are listed in this table shown here. Okay. So, yeah, ito ang mga example natin of these are the common or basic identities of Boolean algebra. Ito yung gagamitin natin to reduce Boolean expression. So, I know you're really familiar with this one. Okay, so here we have to note in this table that each relationship, except for the last one, itong double complement law, meron talaga siyang logical operator. It can be and, o di kaya or. So, yan tinatawag natin na duality principle. Okay? Let's start with the identity law. Okay, so ano ba ang rule ng identity law? What is its concept? Identity law, okay, kindly listen. Identity law states that any Boolean variable, so when we say any Boolean variable, it can be any alphabet, any letter. So, any Boolean variable and, okay, with 1 or di kaya ORed with 0 simply results in the original variable. So, like here, as you can see, 1, gi-and siya with x, the result is also x. When I say x, ito yung original na variable. And here's the OR form of the identity law. Si 0 is ORed with x, and the result is same with x. So, this, which is the original variable. Okay, let's proceed to the null or dominance law. So for this one, it states that any Boolean variable and with 0 is 0 din ang result, and any variable ORed with 1 is always 1. Okay, so that's the rule. For idempotent law naman, states that anding or di kaya ORing a variable with itself produces the original variable. So as you can see, x and x, the result is x. And then x or x, the result is also x. Okay? Now, let's proceed to the inverse law. So the inverse law here, okay, states that anding or ORing a variable with its complement. When I say complement, the equivalent not value of that variable produces the identity for that given operation. So that is inverse law. Now, let's proceed to commutative. Commutative na ba? Yeah, commutative tayo. So, for the commutative law is very easy. Ibaliktad lang ang dalawang variable, no? I-reorder siya or commuted. And then for associative law naman, all you have to do here is you can just regroup each variables, and of course without affecting the result. Okay, so sa associative, as you can see, gibalhin lang niya yung parenthesis, no? From xy ang naa sa parenthesis, nagiging yz ang naa sa parenthesis. So, regrouping ang associative law. Okay, let's proceed naman sa distributive law. So, this is very basic. You have to just distribute, no? Okay, now let's proceed to the absorption law at saka De Morgan's law. So, etong dalawang law na to, their equivalent expression is not very obvious. So, hindi same sa na-discuss na natin na identity, parang madali lang hulaan yung mga equivalent expression nila. For absorption at saka De Morgan, as you can see, ibang-iba talaga yung equivalent na expression. No? So, from absorption, from this expression, naging x na lang siya. And then sa De Morgan's law naman, from this expression, naging ganyan. So, parang ang hirap ng i-guess, no? But actually, we can prove these identities, each of these identities here, by creating a truth table for the various expression. So, try to create the truth table of this absorption law at saka De Morgan's law. You can actually see that they have the same truth value. So, they are equivalent. So, that's for absorption law and De Morgan's law. Now, for the double complement naman, from the word itself na double complement, ibig sabihin, gi-double negation is si variable x. And the result is just the uncomplemented value of x. So, as simple as that. No? So, this is quite famous in the expression like this. Not x. Yan. Negated not x. So, same lang din yan sila. Okay? So, yeah, those are the basic identities of Boolean algebra.